All right, if you weren't here yesterday, we learned that there are actually 4 different methods of factoring, and what you have learned on Friday and then we practiced yesterday was called greatest common factor. And we talked about at the end of class yesterday, well, what happens if there isn't a greatest common factor? So if you were to look at these numbers, we've got a 1, a 12, and a 20. So things that multiply to 1, things that multiply to 12, and things that multiply to 20. And if I were to look at this list, the only common factor that all of the numbers have is 1, right? If I was just looking at the 12 and 20, I could say the common factor is 4. But if I have to bring in all of the numbers, there's only a common factor of 1, and 1 isn't a GCF. And then if I look at the variables, this has 2 x's, this has 1 x, and this has no x. So x isn't a GCF either. So we talked about how if there's no GCF, there's got to be something else we can do. And so we learned that if you're looking at a trinomial, something with 3 terms, and the first term has a equals 1, meaning that the leading number isn't there. So we fill in a 1. We can do this a equals 1 method. A equals 1 only works when the first term is 1 and there's 3 terms. You need an A, B, and C. In the process, we use all 3 letters. A equals 1 because that's what it's called, and then we use the B and the C to find the other number. So you need all 3. So the first thing that you do in the A equals 1 method is you type C, which in this case is 20, divided by x into your calculator. So if I have my calculator here, I do 20 divided by x. And what I'm doing is I'm looking for the numbers in the table that are next to each other that add to B, which in this case is 12. So as I create this table of 20 divided by x, I'm looking for the numbers side by side that add to 12. So here's my table. 1 plus 20 is 21. That doesn't add to 12. 2 plus 10 is 12. Right? That's what I want. I want them to add to 12 next to each other. So my numbers are positive 2 and positive 10. And then once we pick those numbers, they just go into some missing blanks. So every A equals 1 problem has 2 sets of parentheses. And the first part of that parentheses is always an x, because x times x is going to give me my x squared. My other 2 numbers need to create the 12 and 20. And that's 10 and 2, right? 10 and 2 multiply together to be 20 and add together to be 12. And they're both positive, so we put plus signs here. And this is what we get for factored form. And we could check this 2 ways. Yesterday I showed you how you can distribute out to check. So today I want to show you the y equals way. So in y1 I would put what's called standard form, the highest exponent first, and then the order descends, right? So it was 12x plus 20. That's called standard form. And then in y2 I would put my factored form. Factored form is the one that has the parentheses. And they should be equivalent. So to check it, I can check the table. You can see all of the values in the table match, so I know my answer's good. So just another way to check it besides distributing out. All right, looking at the next one, there's no GCF here. So A equals 1, B equals -6, and C equals 8. In the A equals 1 method, when we have a trinomial, 3 terms, first term's 1, we go to the y equals screen and we do 8 divided by x. And we're looking for numbers next to each other that add to -6. So let's look at that. I'm going to do an 8 divided by x. And I'm looking for my numbers to add to -6. But look, 1 plus 8 is 9. 2 plus 4 is +6. 4 plus 2 is +6. 8 plus 1 is +9. None of them add to -6. So where do I have to go? Up. Up in the calculator is going to take me to the negative numbers. -1 plus -8 is -9. -2 plus -4 is -6. So I'm going to use -2 and -4. Remember, my parentheses always start with x's, and now I picked -2 and -4. And so this is my factored form for this one. Make sense? I'm not going to go through like all that process for the next. I'm just going to get some answers for the next few. So did anybody find my factors for this one? Something that multiplied to -36 in the y equals screen and added to 9. What'd you get? What two numbers?
12.
So +12 and -3. All right. I know that that works because 12 times -3 is -36, and 12 plus -3 is +9. So that's a good pair of numbers. That's right. All right, and then let's look at 81. Anybody think they have the pair of numbers that multiply to -8 and add a -7? 8? +8 and -1? So let's think about this. 8 +8 and -1 equals -8. So that works out. But +8 plus -1, that's +7. So what do you think we could do to your numbers and get -7? You got the right numbers. It's definitely 8 and 1. Switch the symbol. The negative's got to be with the 8 in order to create the -7. Does that make sense? All right, so that one is going to be -8, +1. All right, and then one more new voice for this last one. -40 multiplied to -40 adds a +3. Come on. How's it going to make me take my wheel out and spin it? Someone over here. What do you got?
X plus 8 and x minus 5.
I know you guys know it. You just don't want to talk to me for some reason. X plus 8, x minus 5 is good. So this is called the A equals 1 method, all right? We're using our calculator, where some of you can do that in your head. And then you're finding the numbers that add to that middle number. And this is called factored form, all right? So I promise you we weren't doing anything new today. We're not, all right? What I want to do is just talk to you about the difference, because what I want to do today is put both GCF and A equals 1 problems on the same page, and I want you to be able to pick out which method to use. Because by the end of the unit, there's going to be 4 different methods, and I'm not going to tell you which one to use. You got to pick it and then factor, right? So let's figure out the difference between the two. Does anybody remember what I said, or when we use A equals 1? 2 very distinct things have to take place to use this method. No GCF, yup, which is the same thing as saying GCF is 1.
And there can be no x, that's just be a plain 1.
Yup, so no, oh, there can be no number in front, you mean?
Yeah.
So leading term is x squared, no number in front. Okay, one more thing. It has to be a trinomial. If it's not a trinomial, you can't do this. Okay, and then the fancy name for that is trinomial. All right. And so a GCF is kind of like the dumping ground. So if it's not that, it's probably this, okay? So GCF is going to be when numbers have a common factor. That's not 1. or all terms have, and I'm going to say X, but hopefully you realize that it could also be like a Y or in C, right? All terms have a variable, right? If all of the terms have a variable, then there's a GCF. It might not be a number, it's a variable. In terms of number of terms, it can be any polynomial. It can be 2 terms. It could be 10 terms. GCF doesn't care how many numbers there are, whereas A equals 1 does. All right, so what I'm looking for you to do today is look at a polynomial and decide, should I do GCF? Should I do A equals 1? Or maybe, remember at the very end of class yesterday where there was one that was both? Anybody remember that example? So a both example will look something like this. The reason it can't be A equals 1 right away is because the leading term is not x squared. There's a number in front. But we talked about yesterday how we could divide that number in front out and divide it by all of them, and then it becomes an A equals 1. So there are instances where you would use both. We okay with that? All right, so quick check-in, see if you know the difference. You're going to log into Socrative. And all you're doing is choosing the method. You're not actually factoring it. You don't need a calculator or anything like that. I just want to see that you know the difference between the methods before we actually do then go factor them. All right, so here are our results. Pretty good for the first few. So the first one, everybody had right. That was clearly A equals 1. For the second one, it's not GCF and then A equals 1. The key with A equals 1 is it's got to be a trinomial. So this is 4 terms. It can never be A equals 1 with 4 terms. So I think one of you might have picked that, and I get it. When the first term has this number in front, you think I can just divide it out. You can't divide it out here because even if you do divide something out, it's going to be more than 3 terms. So this one's just GCF. Same idea here. Some of you picked GCF and then A equals 1. So you might think, oh, I can divide by 14 and then I've got an x squared. But I need it to be a trinomial to ever use A equals 1. And this is a binomial, so that won't work. This one's just GCF. This one's A equals 1 because it's 3 terms. First term has a 1. There's no GCF here. GCF would mean they'd have to have something you can divide out of them. And the only thing they have in common, 1 and 42, is a 1, and that's not a GCF. So there's no GCF to be able to divide out here. Now this one was tricky. I totally understand the 62% of you that picked GCF. Because to the normal eye, it looks like it would be a GCF problem. It's not a trinomial. There's no leading coefficient of 1, and so the jumping ground would be, okay, this is a GCF, but just kind of think about this one. I tried to keep the numbers small so you could think about it. Numbers that multiply to 9. 1 times 9. 3 times 3. Numbers that multiply to 5. 1 and 5. Do they have anything in common besides 1? No. So even though this looks like it could have been a GCF problem, none of those actually work, because in order to be a GCF problem, there has to be a GCF. And there's not between 9 and 5. So this one was none. I totally get the GCF pick, but it's actually none when you look at the numbers. Next one. This was both. This was kind of like the both example I showed you. Even though A doesn't equal 1, if I divide all of these things by 3, then A equals 1. And if I'm dividing a 3 out, that's called taking out a common factor. 3 would be the GCF. So I took out a 3, and then it would be A equals 1. So this one was both. And then finally, this was none of these. I could see why some of you might want to pick GCF. It definitely can't be A equals 1. Why can't this be A equals 1? It's not a trinomial. A equals 1 only works with 3 terms. So it can't be A equals 1. And GCF maybe, but I'm looking at the number 1 and 16. So the only thing 1 and 16 have in common is 1, so there's no GCF. So this one was none of these. None of these would work here. All right? So now that you've seen that, now we're going to start to do practice like that. So like, look at the problem, identify the method, and then use the method. So this is the first time you're going to get a practice separating the two methods. What we did in Friday's class versus what we did in yesterday's class. Knowing which one to use and then applying that. All right? So we're going to do a few together, and then I'm going to have you do some on your own. So workbook page 27, there's nothing new here. I'm not teaching you anything new. I just want to walk you through my process of how I would approach these problems so that when you go to try to do some, you have methods to approach them, all right? So workbook page 27's got these 3 examples. When I look at example number 1, I immediately notice that it's a binomial. The fact that it's 2 terms means that it can't be the a equals 1 method, right? Because 2 terms can't be a equals 1. A equals 1 needs 3 terms. This doesn't have 3 terms, so it can't be a equals 1. So in my brain, I'm thinking, okay, maybe there's a GCF, all right? So I'm going to try GCF. You could list out the factors of 24 and 42. 42 is a lot of factors, though. So I'm just going to refresh your memory on how you can use your calculator for this. You can do a math, arrow to the right 9. And what happens when you do that is this GCD comes up, which is the same thing as GCF. And then you can do a 24 and 42. Remember, with the button in the calculator, you can't put negatives in. So even though that's a negative 42, I'm not going to put that. So I'm going to do math, arrow to the right 9, of 24 and 42. And I'm going to see, okay, well, they have a GCF of 6. All right. And then this one has an X, but this one has no X. So the GCF doesn't have an X. All right. So my GCF is 6. No X with that. It would only have an X if the 42 had a 6 as well, and it doesn't, all right? So my GCF is 6. What do I do with that? I take the problem, which is 24 x minus 42, and I'm going to undistribute a 6. So distributing in is multiplying, distributing out is dividing. So I'm going to divide each of those numbers by 6. 24 divided by 6 is 4. The x's don't cancel out, they just stay. And negative 42 divided by 6 is negative 7. And you are undistributing it, which means it goes to the front of the parentheses. So just a refresher from what we did on Friday, that's how you factor out a GCF. You identify the GCF. Sometimes it has an X, sometimes it doesn't. And then once you identify the GCF, you divide it out. It doesn't go away, it goes to the front of the parentheses. All right. For this next one, I see I've got 1, 2, 3 terms. First term is x squared with no number in front of it. When I see something that's 3 terms with no number in front of it, this is the a equals 1 method. So in the a equals 1 method, we have an A, we have a B, and we have a C. I'm definitely going to use my calculator for this one. Negative 120 is a pretty big number. So what I'm going to do is go to my y equals screen, and I'm going to do a negative 120 divided by x. And I'm going to look for numbers next to each other. That add to negative 14. And those two numbers are going to go in these spots. The x times the x is taking care of the x squared. So now I'm focusing on the negative 14 and the negative 120. So in my y equals screen, I'm going to do a negative, because that minus sign goes with it, 120 divided by x. And I'm gonna go through this list. So I'm looking for, what was it, negative 14? So that's positive 119. That's positive 58. That's positive 37. I'm not looking like I'm going in the right direction when I go this way because I'm getting a lot of positive numbers. So I'm going to go this way instead. All right. So 1 plus negative 120, that's negative 119. 2 plus negative 60, that's negative 58. 3 plus negative 40, that's negative 37. 4 plus negative 30, that's negative 26. 5 plus negative 24, that's negative 19. 6 plus negative 20, that's negative 14. So positive 6 and negative 20, that combination makes the negative 14. So it was positive 6, negative 20. And this is my factored form for that one. All right, so this is how we do A equals 1 method. So it's making sure you can understand the difference, right? When do I use GCF? When do I use A equals 1? And then how do I use both of them? All right, so the last one is 3 terms. So I'm thinking A equals 1. But the first term has a number. So I can't use A equals 1 yet. But can I get rid of that number? So the number itself is 2. So can I get rid of the 2 by doing this? Sometimes you can't. Like if I do divided by 2 and I'm going to end up with a decimal, then I can't do that. And there's another method for that you're going to learn on Thursday. All right? So check to see if you can divide that number out. If you're going to get a decimal when you divide that number out, then you can't do GCF. Okay? But if you can, I'm going to get a whole number from all of these. X squared minus 45x plus 200. I can divide them all out. Now, A equals 1, B equals negative 45, and C equals 200. So I can do 200 divided by x, and I'm looking for those numbers to go in my blanks. I want them to add to negative 45. So let's see what we've got. 200 divided by x. I want them to add to negative 45, so I'm going to go in this direction. Negative 5 and negative 40 add to negative 45. Does anybody see what I'm missing? The 2. This is a GCF of 2. GCFs go to the front of the parentheses like they do in this first one. So when I divide out that 2, it doesn't disappear. It goes to the front of my parentheses. So I factored out the 2, then I did A equals 1. So I just wanted you to see concrete examples of each of the 3 methods. 3 meaning just GCF, just A equals 1, and both. We okay with that? All right, so our closure today, you've got, 20 minutes here. You are going to do some of these on your own, and you're going to come and check in with me. So if you go to page 26, column A has a little bit of both. Okay, so it's got some GCFs, it's got some A equals 1, and then I think it has one that has both. All right, so you're going to factor column A out, and then you're going to come check in with me when you finish. Anchor would be Math Excel. You have extra time. I told you you would have time in class today. You probably should have some time in class today. So you can work on Math Excel numbers 1 through 16 are GCF and A equals 1 problems.